Hi. So I want to cover some of the material that Bobby and Phil talk about, but in a little more detail. So I made this video so that you can get what I have to say without having to be in a synchronous session. So um, the key idea here is this quote from Deming is that um, failures and defects are generally deficiencies of systems and process and management rather than human cause. The role of management in uh, continuous improvement is to change the process rather than harassing people to do better. If people fail, it's management's fault. That's the essential idea. So some terminology, quality, as you can see. So this is conformance quality. We have standards for what a process is supposed to deliver. And if it meets those standards, it's said to have high quality. This is not quality in the sense of whether something is cool or new or innovative. This is quality in as it does what it says it's going to do. And conformance quality, you can actually measure quality against those standards and identify defects and improve. So the idea of quality control is improvement. When you're in a system that's concerned with quality, then it's very common for the firm to have quality assurance, which is people who are not doing the work themselves, not the people who create the defects, but people who look for defects, so that the quality is assessed after the process is complete. And it helps you keep defects from reaching your customer. That's a little bit different from a total quality management approach in which the defects are the responsibility of the people who are doing the process. So total quality management means that the workers who do the work are responsible for quality. They measure it, they analyze it, they fix it. One of the tools they use is statistical process control. We won't get into statistical process control in this class, but it is a big piece of what you would learn in an operations management major. And this is why one of the reasons why you need to take your statistics course seriously is because in the world, people do statistical process control all the time. You need to know how to do it. And then Six Sigma refers to the acceptable level of defects in a process. So Six Sigma is actually 6 standard deviations above the mean. Sigma is the symbol for standard deviation. So what it says is that we have the likelihood of a defect is 6 standard deviations. 3 standard deviations are above or below the mean, which means that you should have about 99.9% defect free. Now, excuse me, actually, that's 3 sigma. 6 sigma is more like 1 defect per 3 million. So it's a very tiny number of defects. It's actually a sort of a way of thinking and way of doing that's very disciplined and rigorous, and we'll drive it out. You can get a 6 Sigma certification. They're very desirable in a lot of the businesses you'll work for. So definitely something to think about as you become a manager, especially if you become an operations manager. The DMAIC process is part of Six Sigma. It's another tool that we use in Six Sigma where you define the problem, measure your performance, right? Not just guess at the performance, but measure it. Once you've measured it and you know what your defects are and why they're what they are and how often they happen, then you look for root cause. You do root cause analysis of why the defects happen, and then you can improve the process by fixing those root causes. If you don't fix the root causes, you won't reduce defects. And then over the long run, you control the process to make sure that defects are not creeping back in, that you don't have new defects arising. And then you define the problem again and you keep going. And this is a continuous process. It's called continuous improvement. And you may solve a lot of easy problems first and find them harder and harder to fix as you go on, because you'll fix the easy ones first. And but it is a continuous improvement tool that we're going to actually use. And then finally, for this ISO 9000 is a international standard for quality, where you self-document your quality processes and then are certified by a third party. You want to work for a company that's got ISO 9000 in place. And most of that's developed around product manufacturing and product delivery. It also applies to service delivery, as we see in the Ritz-Carlton case. There are some unique things about delivering service. It's perishable. The airline seat that you don't fill is gone once you close the door. The service you deliver in your restaurant today doesn't count tomorrow. Where you deliver service matters. That may be the location for a hotel or a restaurant, but it also may be whether you do it in your own facility or in the customer's environment. So plumbers tend to work in the customer environment when they provide service. Some services are harder to scale up than others. So you can see this in the range of retail outlets, for instance. So you have small, high contact, high service retail environments, and on the other end, you have Walmart and Amazon. Some services don't scale up very well: plastic surgery, dental processes, funeral homes. So it's different from scaling up product development or product production. Performance, because you perform the service over and over, there's likely to be a lot of variation. You don't have anywhere near as much control over the process in the service environment as you do in the manufacturing environment, and then perceptions of quality are also different. In service delivery, the customer is always involved. Now, how close the contact is can vary, but the customer is always involved in some way. And so the service provider interaction is very critical. So when we talk about the Ritz-Carlton case in particular, you have to think about, we're delivering a service rather than a product, and what does that do to perceptions of quality. So that's it.